In 7a, we will work with odds. The definition is as follows. So for an event A, the odds for event A are a ratio. The first number that is given is the probability of that event A occurring, and the second number that is given is the probability of that event not occurring. Sometimes this is presented as a fraction, or this may be presented in sentence form, where instead we say the probability of A to the probability of B, or use a colon. For odds against, you're going to switch those numbers. So for the odds against event A, the denominator and numerator swap. So here you see the probability of not A to the probability of A. Now, occasionally other textbooks, or you may see other online sources, might use a bit different terminology than we'll use in this textbook. For instance, odds on generally mean odds against. But in this book, for the problems that you see, these will be the ideas that you'll focus on. So odds for would be the probability of something to the probability of that event not occurring, and then odds against would be the opposite. In an example, here we're going to discuss two fair dice which are rolled. We're going to find the odds for and the odds against tossing doubles. Now, if you'll recall, the probability of rolling doubles is 1 out of 6. The probability of not rolling doubles would be 5/6. So to state this in the form of odds, you'll see here that we didn't leave the fraction. This is in an appropriate form, similar to what we were just discussing, so I'll walk you through it. The probability of rolling doubles is 1/6. That may be my numerator, according to the last slide. And then if I put that over 5/6, the probability of not rolling doubles, 1/6 divided by 5/6, you have fractions inside of fractions. The denominators cancel there, the 6, so that it's really 1/5, or written in words, 1 to 5. So sometimes instead of a fraction, we write this in this form, 1 to 5, or use a colon between these, so 1:5. You'll notice that that is saying 1/6 to 5/6, but it's somewhat of a simplified form for odds. The odds against, you would switch the numbers. So if you know that the odds for something are 1 to 5, then the odds against would be 5 to 1. So this is saying 5/6 of the time you will not roll doubles, and then 1/6 of the time you will roll doubles. To get that denominator, you can add the numbers together, and that's how I can tell that this is really 5/6 to 1/6. The probability of rolling double threes is 1 out of 36. So the probability of not rolling double threes would be 35 out of 36. To present this as odds for, we could say that the odds for rolling double threes are 1/36 to 35/36. Since we try to keep away from fractions, we typically will cancel those denominators and will instead say the odds for are 1 to 35. Odds against would be 35 to 1. So we'll work with some problems using the counting property. The counting property says that when you are faced with a set of choices, and for each choice you have a number of different options, then to determine the total number of outcomes possible, you're going to multiply the options for each choice that you must make. A simple example would be when you get dressed in the morning. So let's use this baseball uniform as an example. Here, I might need to choose a hat, a top, and pants here for my baseball uniform. My 3 decisions are the hat, the shirt, and the pants. Now, for a hat, I have 3 options. For a shirt, I have 2 options, and for pants, I have 2 options. So the total number of outfits that are possible using these items here would be 12. And the way that we get that is we take the product of the number of options we have for each choice. So my first choice, 3, my second choice, 2, and my third choice, 2. I find the product of those, and I get 12 possible outcomes. This might remind you of going to Subway, or suppose we go to a diner to order a sandwich. At the particular diner, there are 3 options for bread, and we must choose one type, 4 types of cheese, and we must choose one type, and then 5 types of additional toppings. So vegetarian, ham, turkey, chicken, and tuna. How many different single topping sandwiches with cheese are possible? Since we must choose a type of bread and there are 3 options, then we'll take 3 times the number of options we have for our cheese times the number of options we have for our single topping. There are 5 options here. We find this product is 60. So there are 60 different single topping sandwiches with cheese at this particular diner. This is how to use the counting property.